Hello everyone, welcome to our channel Zeal for Python. Today we will learn about lists and tuples in detail. Lists are the ordered collection of objects and are considered as group. Objects in list can be accessed by their offset and they also maintain an order from left to right, hence called as positionally ordered. As the lists are mutable, they change in place. List can contain objects of different data types. List can also be nested in another list. The position of objects in a list are called indexes. The first element starting from left have positive start index starting from 0. The list can also be accessed from right to left by using negative indexes starting from -1. Just like string indexing and slicing can be performed on the list, but the change in the list after these operations will change an entire list in the same memory location. Let us see an example of indexing in list. Suppose we have a list L with elements 1, 2, string zeal, and then another string Python. If I have to access zeal, I will have to mention its index like L in square brackets. I will mention the index 2. As you can see here, the first one is 0. The first index will always be 0 if we start from left to right. So 0, 1, 2. It will give me zeal. If you want to check the length of your list, you can use len method and it will give the length of your list, which is 4. It means your list contains 4 elements. Slicing gives the entire section of the list whose indexes are mentioned. If you can see here in list, 2 indexes are mentioned. The first one is lower bound, the another one is upper bound. Lower bound is always inclusive and upper bound is non-inclusive. For example, while slicing, if I mention the indexes 1 and 3, it will include the element present at index 1, but it will exclude the element present at index 3. In slicing, you can also include third index, which will be considered as stride. If you try to access list index greater than its length, it gives an error called index error and it states list out of range. For example, in this, if I try to access the element at position 5, which is not present, which is greater than the original length of our list, it gives me an index error, that is list index out of range. But while slicing, if index greater than length is mentioned, it gives all the elements of the object. That is, while slicing, if instead of 3 I am giving 5, which is out of range, it is greater than, okay, it will give me till end whatever the list of elements are there in the list, it will give all the elements to us. While slicing, if no index is mentioned, then it gives entire list and makes a copy of the list in new memory location if it is assigned to a variable. What does this mean? If I am writing L and I am not mentioning any variable, any index, it gives me an entire list. If take a variable, say L1, and I assign the value of this to L1, it will give me copy of L. Okay, then changing list value. If we have to change a value of list in place, we can use the methods like indexing. Some type specific methods can be used. Okay, let's see them one by one. For indexing, if I take a list 2 and it has value says one string zeal, another I have a tuple which has elements 2020 20 and another element is a number. This is my another list, list 2. Now suppose if I have to change the tuple, change this tuple in the list, I have an option, I will use indexing. List 2 at first position, instead of this, I want to include 2020, 20, then September. I want this tuple instead of the original one. It gives me another list. This change in list 2 is in place change. Using type specific methods like append and extend, we can also change the value of list. While we will use append, the element which will be mentioned will be considered as a single element, and for extend, the elements are added as multiple elements. For example, in list 2, if I have to append elements like 1, 2, it will be considered as one single element. It is considered as a list here. Whereas if I will use extend, it will be considered as multiple elements. The change in this list are all in place change. Hence, whatever the new list is obtained, it is in place in the same memory location. Basic operations on list. Now, just like on string we performed concatenation, indexing, slicing, repetition operation, these operations can also be performed on list. See here in this example, I have a list I have taken a list. I have taken a variable L1 and two lists are here which are concatenated using a concatenation operator. It will give us a result or in L1 variable of the two concatenated list. As lists are positionally ordered, they can be indexed and sliced also. While indexing, if I want to index this L1, that is if I want a element present at index 2, I will just have to mention the index, that is L1 2, it will give me the element present at that particular index. Slicing will give me the section of elements or section of that list whose indexes are mentioned. This is lower bound, this is upper bound. So it will consider element present at position 3, but it will not include the element present at position 6. Repetition repeats the same list number of time mentioned. Here L1 repeat 3 times. So the L1 is repeated 3 times. Like numbers and string, lists also have their own type specific methods. All the supported methods of the object can be viewed by using dir method. Many of these methods can be used to change the list in place. For example, if I have to check for list, I will do dir list. It will give me all the supported methods. These are few support type specific methods in list. Sort will sort the list in ascending order. Append, as I told before, will append the object as a single element. Extend will extend the list, that is, it will add the elements multiple as a multiple elements. Pop will delete and return the last element. Reverse reverses the list. Index, it will give the index of the object mentioned in the list. Copy will copy the list. Delete list index. This will delete an object mentioned at the index. Now let us learn about tuples. Tuples are sequence-based positionally ordered collection of objects that can't be changed. As they are positionally ordered, they maintain left to right order. They can be accessed by their offset. They can have different data type object. As they are immutable, they cannot be changed. That is, they have fixed length, unlike list which can be extended. Tuples are enclosed in parentheses. Tuples support basic operations like concatenation, repetition, indexing, and slicing. But upon performing these operations, they create entirely new tuple in different memory space. Basic operations examples, we can see we have a tuple T1. If I have to concatenate it, I'm concatenating T1 with another tuple which has these elements. It will give me another tuple, but this tuple is entirely new one in new memory location. T1 is just referring to this object. Repetition, it is repeating the tuple 3 times. Indexing and slicing in tuple can be used just to view or access. Like if I want to check the what is present at index 2, I'll just use this and I will check what is present. Tuple 1 index 2, it will give me what is present at index 2. Slicing will give me again the section, just like we have learned it in list. Now changing tuples. In place change for a particular object in tuple is not allowed as it is immutable. Using indexing and slicing, we can only view the object but we cannot change. If using here index, if I try to change the value of the object by using index method, it will give me a type error and it will state tuple object does not support item assignment as it is immutable. But if I want to change or if I want to really perform some operation on my tuple, if I have to change it, what can I do is I can convert the tuple to list. How is it possible? To convert the list into tuple, we have a method called list. For example, I have a tuple, say T. I will use comma 3. if I want to perform any specific operation on tuple, like changing its value or through indexing, what we can do is we can convert this tuple into list using list method. See, in T I will get my list. Now I can change it for say 33 at index 4. In place of 33 I want 9. I got a new value in place of 33. Now again I can change this into a tuple, list into a tuple using tuple method. See, so in tuple supports very few built-in functions, but you can convert the tuple into list and perform the desired methods and again convert it into tuple. The method which I showed can be used. See, few methods like sort and is not possible in tuple. So if we have to sort this tuple, what we can do is change it into list, sort it, and then again convert it into tuple and assign it to the same variable. These are the type specific methods or supported methods of tuple. Length, which will give us the length of our tuple. Count, which specifies the number of time the value is specifies appeared in tuple. Index returns the position of the value specified. Now how to create an empty list and tuple? To create the empty list and tuple, we have two methods. The first one is just take a variable and take a square bracket, empty square brackets, or you can take a variable and use a list, call a list method. Similar way, tuple can be created, empty tuples can be created. This is all about list and tuples. Thank you for watching our video. Please do like, subscribe and share. Please let us know your comments or your queries through comments. Happy learning.